Welcome to an Introduction to Python, Overview, and Packages. These materials are available locally through this link if you're running Docker or Anaconda, something to run a Jupyter Notebook locally, via GitHub, or via this button you can generate the slides automatically. We're going to go over a variety of the different features of the Python language and why it makes a great foundation or language for data science. We'll talk about Python and Jupyter. Jupyter is a great environment for working with data science, or working with Python in context of data science. We'll get into Jupyter and Markdown, Python 2 versus Python 3. As I mentioned earlier, we'd be working primarily with Python 3 in this series of lessons. And then finally, we'll talk about Python and packages in a very short exercise. Python is a very full-featured language. You'd expect the same types of functions and features of other programming languages if you haven't worked with Python before. Python is object-oriented, as is R, and it is a one that has a variety of different data types and functions that are included with the language, and an extensive ecosystem of packages by which you can extend the functionality of the core language, add additional data types, add additional functions. And so it's really the power of this ecosystem and the large groups of individuals that are using Python as a platform for data science that make it extremely powerful. One aspect of Python is that it is an interpretive language. This means that in contrast to something like Java or C that are compiled language, we can feed individual statements and the interpreter can act on that. So we don't have to kind of go through packaging and bundling our code in order to generate an executable. This works well for data science because we can use it in an interactive mode. When you're working with Jupyter Notebooks, and this is probably one of the first times you are if you're just starting these lessons, you've got a great series of different functionality that you can execute by simply pressing the play. If you, for example, wanted to add 5 to 5, you can do that within a Jupyter Notebook, and it will act just as a calculator would. You can also select a variety of different kernels. So if you were to want to use Jupyter with R, use Jupyter with Scala, or even Sass, there's a variety of different tools available to be able to do that. You can read more about Jupyter Notebooks in this link. And another important thing to note is that if you're providing a variable or listing a variable, it'll be provided as output. So listing G provides the G as an output. Markdown is also an important aspect of what makes Jupyter Notebooks so powerful. It allows you to rather simply take your Jupyter Notebook, make it into something that will appear nicely in terms of documentation and formatting that can be utilized in slides, as in this case, or just for the edification or documentation of for the next coder who may be coming across your work. It could also be useful in providing some type of interactive reporting where somebody could input some details that they would want for a particular report, and then retrieve a formatted output. Python went through a lot of changes when going from Python 2 to Python 3. In many cases, the data science community has been stuck in Python 2 for a good amount of time, but Python 3 is definitely increasing extensively in terms of the adoption amongst people doing data science. And the variety of common packages will be available both through Python 2 and Python 3. When you're just getting started, one of the main things that you'll notice is the print statement works differently. Often you're going to be in these interactive tutorials printing things out by, say, here printing hello world. When doing that in Python 2, and you could verify this by changing the kernel and executing the statement, this will work just fine. In Python 3, you've got to use parentheses. And if you're getting just started with Python, the things you'll see in these lessons will be Python 3, so we don't have to worry about it. But if you're adopting little bits of code that you might find online, this is one of the early gotchas with Python 2 versus Python 3. So as I mentioned, there are a wide variety of packages that extend the capabilities of the Python language. You can refer to the Python package index to see what packages might be available if you have a very specific need, say accessing data via an API or something like that. It is possible that there would be packages available for Python 2 and not Python 3, and vice versa, so that's always something to consider. And in order to manage packages, we use something called PIP, and the Python to install and manage the Python packages. So PIP is a package management system, and it must be run in the terminal. And when we say run in the terminal, it's really, you can still actually do that from within the notebook, but adding a single exclamation point before whatever command that you're running will tell the Jupyter Notebook to run it within the terminal. You can also access the terminal directly if you're using something like Docker or Anaconda by clicking on New Terminal. And if you're using the Docker Notebook, you can also execute Docker command in order to gain access to the underlying operating system. But most of the time when we're doing things, we can just add an exclamation point. For example, pip install matplotlib will install a variety of packages and some packages required in order to execute that package. Even if we have a package installed, we've got to import it before using it. Often Python packages are organized as modules, and you can choose to either install the entire package or just the submodule that you need. Packages only do have to be imported once in a notebook, so if you've imported it at the top of the notebook, you don't have to re-import it if you use it later on down in the notebook. There are a variety of different ways you can use to import packages. So first you can just, for example, import the package matplotlib. Alternately, if you wanted to just import the module pyplot from matplotlib, you could do that in two different ways. So you could say import matplotlib.pyplot or from matplotlib import pyplot. In addition, there's a lot. It's often relevant to abbreviate a package. So if you are importing specifically the module matplotlib.pyplot, you can import that with the abbreviation PLT, and thereafter, when you're accessing it, you would be able to utilize that abbreviation in order to be able to call one of the methods within that package. For example, here you can see after we've imported the package as PLT, we can then also execute the plt.plot as well as calling the module that we've imported separately. So now just for a short exercise regarding packages, I'd like you to go through and just import the NumPy packages. This is something that should be installed by default, either in Anaconda or whatever Jupyter environment you're working with. But first, I want you to verify that NumPy was installed. How did you know? What are the things that really told you that this packet or this package was available in the operating system, or whether and could be imported, or whether it was not available and needed to be installed. So next, I'd like you to provide the code so that this statement down here, which calls the NumPy array or NumPy array creation routine, would function correctly. And then finally, import NumPy as the abbreviation NP and created a value, an array E2 with the values 5, 6, 7, and 8. So once you've done that, that should be pretty simple. You can continue on with the exercises. And that's it for